Hello everyone, I am Jeannie Gogoi from Dibrugarh University. Today I am presenting with my co-author Kalyan Bhuya, and our research is on ionospheric signatures associated with sudden stratospheric warming or SSW episodes over Okinawa. The ionosphere is the layer of ionized gas in Earth's atmosphere in between the neutral atmosphere and the magnetosphere. It is a complex dynamic system that is affected not only by the Earth's magnetosphere and the solar processes but also by the processes occurring in neutral atmosphere. SSWs are dynamical events in physical climate system caused by the interaction of upward propagating planetary waves and stratospheric zonal mean flow during the winter months that actually leads to rapid temporal changes in stratospheric circulation and temperature distributions. These events can be classified into major and minor warmings. If there is a warming towards the pole accompanied by the reversal of zonal mean zonal wind at 60-degree northern latitude, we call it as major event, while if the winter westerly weakens but does not reverse its direction, then we call it as minor event. Now the transition phase of winter stratosphere into the summer mode, when easterlies are developed that persist until the following winter, that is called as final warming. Now, although the effect of SSWs on the ionosphere was hypothesized several decades ago, it has been extensively studied in the last few years only. In this work, we have carried out a comparative study of major and minor SSW events that occurred in the northern hemisphere and ionospheric response to those events by using F2 layer peak electron density and virtual height of F layer. In this work, we have used various datasets. We have taken reanalysis data from MERA2. We have taken model data from Mimosa, which is a high advection model, high resolution advection model. We have taken SEBAR data for temperature, and for ionospheric parameters, we have taken ionoson data from ionoson located at Okinawa, Japan, and we have taken geomagnetic data from Omniwave. Well, depending on the type of SSW, so we have taken four examples, that is, four winters having a single major SSW on 2012-13 winter. Well, this winter 2012-13 denotes a period from 2012 November till 2013 March. Next, for the winter with one major and one minor SSWs, we have considered 2007-8 winter. Then for single minor SSW, 2015-16 winter, and for multiple minor events, we have taken 2002-3 winter. So these dates are actually the central dates of the events. Now the temperature and zonal wind profiles of these winters are shown in figure 1, where the upper panel shows the temperature profile and the lower panel shows zonal wind. Now the red color curve shows temperature profile and the zonal wind profile for 2012-13 winter, which shows that temperature increases abruptly almost for a month, and zonal wind reverses with a central date on January 6. Now 2007-8 winter is shown by the blue curve here. Sorry, yeah, this blue curve. So this is a minor event and this is a major event. So the central date of minor event is on January 24 and major event is on February 22. Now single minor event is noted on 15-16 winter, denoted by this green curve. So this is the minor event, and for two minor SSWs, it's shown in yellow curve. It is the first minor and this is the second minor event. If we see the SABRE temperature profiles over Okinawa, this is for major event of 2012-13 winter. So there is an increase in temperature at the stratopause level and mesospheric cooling here. So the central date is on January 6, but we can see its effects over Okinawa till January 21. So it's really for a long period of time. So if we see the ionospheric profiles, so we can see enhancement of FOF2 during noon time till midnight and enhancement of base height up to 100 kilometer during the morning hours. And if we see DST index values during this period of time, we cannot notice any intense geomagnetic storm during this period of time. Hence, we can say that these ionospheric variations are because of SSW event. Now for the major event of 2007-8 winter, we notice a double stratopause here and mesospheric temperature inversion here. And for the minor event of the same year, we have noticed only increase of temperature in stratosphere. So if we see the ionospheric profiles for the minor event, at first there is a drop in FOF2 and then enhancement. So if we notice the temperature profile, this blue curve, there is peak of temperatures, almost 4 peaks, and after every peak there is an enhancement of FOF2 here. So if we notice the DST index values, there is no any intense geomagnetic storm for the whole period. So we can again say that these variations are because of SSW events. Now if we see the minor events of 2015-16 winter, there is an increase in temperature in the stratosphere and mesospheric temperature inversion is there. So if we see the ionospheric profile, there is an enhancement of FOF2 from noon till night, and there is an enhancement of base height also during the morning hours. So if we see the DST index values, there is an intense geomagnetic storm after 28 February this, and exceptionally for this winter we have a final major event. So this enhancement of FOF2 afterwards, this part, this can be due to both the DST index fluctuations and SSW even. Now if we see minor SSWs of 2002-3 winter, for both the minor SSW there is an increase of stratospheric temperature and the mesospheric temperature inversion for the second event. So the ionospheric profile shows that for the first minor event, at first there is a drop in FOF2 then enhancement, and for the second part there is an enhancement only, but it is less than the first event. So if we see base height profile for both the events, there is enhancement of base height at morning hours. So if we see the DST index values, we cannot notice any geomagnetic storm during this whole period of time. So we can say that these ionospheric variations are also because of SSW events. So if we want to summarize the whole thing, and those single major or minor events are stronger than the multiple events, first point. Then secondly, we can notice temperature changes over Okinawa during these whole events. We can notice double stratopause for major event of 2007-8 winter, and for all the events, for most of the events, we notice mesospheric temperature inversion as well as mesospheric cooling. Well, mesospheric temperature variations are mainly due to gravity wave drag. The weakening and reversal of westerly stratospheric winds lead to more eastward propagating gravity waves. Upon breaking, those waves increase eastward forcing, and it leads to reversal of mesospheric winds and also alternate the residual circulations that in turn results in adiabatic cooling of the mesosphere. Now, normally planetary waves and gravity waves are responsible for formation of two stratopause, but combined wave activities and gravity wave breaking and associated turbulences might also cause cooling near the stratopause, which eventually form double stratopause. Now we have seen ionospheric changes because of all the events, and ionospheric perturbations at this latitude during SSWs are considered to be caused by the disturbed E region dynamo or by altering the vertical propagation of planetary waves. Now, we have noticed prominent nighttime enhancement, and this may be due to significant role of F dynamo because of F2 region Pedersen conductivity. For 2002-3 winter and the measure SSW of 7-8 winter, we observe negative deviation of FO2 during peak polar warming. And what happens actually is during SSW, sometimes wave related thermospheric temperature increases, which leads to decay of O2 N2 ratio, which in turn results in decrease of FO2. So these are results of our preliminary research, and our next work is to find out the periodicities of ionospheric parameters. So thank you very much for your kind attention. Any questions or suggestions are most welcome. You can write it to me to jinnygogoi@gmail.com. And yes, thank you again.